अच्छा बच्चों, आज हमने पढ़ना है कैलिब्रेशन कर्व्स, सीआरओ और फिर हम शुरू करेंगे कैनेमेटिक्स। तो आज की क्लास में जो हमारे दो टॉपिक्स हैं मेजरमेंट के, दे आर कैलिब्रेशन curves and CRO. In our syllabus, we only have use of CRO, not its structure or working principle. So we'll only focus on use of CRO. First of all, calibration curves. And before calibration curves, we have to define calibration. And before defining calibration even, we need to define some terms related to calibration. So the very first term we have defined is the actual quantity of an instrument. So the first thing that we have to understand is what is meant by actual quantity of an instrument. An actual quantity of an instrument is, it is the quantity an instrument has to read. So this is the main quantity for which an instrument is designed. Then you have to define the apparent quantity. Apparent quantity, you must say, it is the quantity that is read by the instrument it is the quantity read by the instrument and is converted to actual quantity through proper calibration. So apparent quantity is the quantity that is read by the instrument, and then later on it is converted to actual quantity through proper calibration. So this is the definition of apparent quantity. We cannot understand this concept without looking for examples. So let's take example of some instruments. So name of instrument, what is the actual quantity and what is the apparent quantity. So three things. First of all, instrument. then we have actual quantity, and then we have apparent quantity. Let's take an example of number one, mercury in glass thermometer. You studied mercury in glass thermometer in your O level, so this would be a common example for you. The actual quantity for a mercury in glass thermometer is temperature. And the apparent quantity through which it reads the temperature is, it reads length of mercury column. So length of mercury column is converted to temperature. So what it reads is length of a mercury column. So in a mercury in glass thermometer, length of a mercury column is converted to temperature. So the actual quantity is temperature, and the apparent quantity is the length of a mercury column, which is later on converted to temperature by proper calibration. Second instrument that we take as an example is an analog fuel meter. All the analog meters have apparent quantity, that is angle moved by pointer, or so all the analog instruments will always have an apparent quantity, that is angle moved by the pointer or the angle of deflection. While on the other hand, the actual quantity would be the, as you see, for analog fuel meter, it is volume of the fuel. One last example as an instrument is an electronic balance or a top pen balance. I hope you studied this in your O level. So an electronic balance, or it is also called a top pen balance. In your O level, you studied a top pen balance or electronic balance. Then you also studied a Newton meter or spring balance. And I believe you studied the beam balance. So these were some balances in your O level syllabus. What is the look of this top pen balance? It looks like this. Maybe it will clear the idea of what I'm saying. A top pen balance looks like this. And here you have reading in grams. So a top pen balance, its actual quantity and its apparent quantity. It is designed to read the weight. And instead of weight, it reads the push applied by the weight on the top pen balance, and that push is called the contact force. So without going in minor details, and these are just examples. Even if you have no idea about top pen balance, just skip that. At least you understand the idea of mercury and glass thermometer. Basically, what you have to understand is that every instrument has to read a quantity that is called the actual quantity. And instead of reading that quantity, it reads some other quantity and then converts it into that quantity, and this process of converting is called calibration. Now, if we define calibration, calibration is basically developing a relation between the apparent quantity and actual quantity of an instrument is called calibration. So, developing a relation between the apparent quantity and the actual quantity of an instrument is called calibration. This is the definition of calibration. Then, when they ask you about what is a calibration curve? If you develop this relationship on a graph, then that graph is called a calibration curve. So a graphical relationship, a graphical relationship a graphical relationship between the actual a graphical relationship between the actual and the apparent quantity between the actual and the apparent quantity of an instrument between the actual and the apparent quantity of an instrument of an instrument is called a calibration curve. So a graphical relationship between the actual quantity and the apparent quantity of an instrument is called calibration curve. Now, there are some terms related to calibration curve that you need to understand. Generally, students are confused in sensitivity and precision. You have to understand the difference between the sensitivity and the precision. I will try to explain that. Generally, it's a confusion in students, like they mix sensitivity and precision. What is sensitivity? Sensitivity is related to size of a division on an instrument. So sensitivity is about size of division on an instrument. So instruments with bigger divisions are more sensitive. However, precision is a different thing. If they ask you about precision, then precision is basically about value of so this is the difference. This is size and this is value. Value of a division on an instrument. So sensitivity is about size of division and precision is about the value of division. Let's suppose you're given with a thermometer. It's a mercury in glass thermometer. And these are the divisions on this thermometer. The divisions are 0, 1, 2, 3, 4, 5, 6, 7, and degrees Celsius. This is thermometer A. You get another thermometer. Let's suppose that thermometer is thermometer B. Values are 0, 1 degree Celsius, 2 degrees Celsius, 3 degrees Celsius. This is B. No, value of one division on A is 1 degree Celsius. Value of one division on B is 1 degree Celsius. So value of division is same. Value of one division, value of one division on A and B is same. Value of one division on A and B is same, which means that A and B are equally precise. So precision is about the value of the smallest division. So you can say that A and B are equally precise, since both of them have a smallest division of 1 degree Celsius. So they have same precision. What about sensitivity? B is more sensitive as it has bigger divisions. So an instrument with bigger divisions is said to be more sensitive. So B is more sensitive just because it has bigger divisions. So this was the concept of sensitivity. If you want to get a more precise instrument, then if this is just, for example, an instrument X, and you get another instrument which is just, for example, instrument Y, divisions on Y are 0. Let's suppose it is 0.1, 0.2, 0.3, 0.4 degrees Celsius. Now you see one division on X is of 1 degree Celsius. One division on Y is of 0.1 degree Celsius. So we can say that Y is more precise as its least count. What is meant by least count? The value of the smallest division. So least count is the value of the smallest division, as its least count is smaller. So this is the difference between sensitivity and precision. Sensitivity is about size of division, while precision is about value of a division. Now let's go with exam definition of sensitivity. If you want to define sensitivity in your exam, then the exam definition of sensitivity would be, first of all, to understand the concept, let's define sensitivity of a mercury and glass thermometer. You know, in a mercury and glass thermometer, the length of mercury column represents the temperature. The temperature is the actual quantity, and the length of mercury column is the apparent quantity. So if it is mercury in glass thermometer, and you see the actual quantity is temperature here, and the apparent quantity is the length here. So basically this change of length is converted to this change of temperature. So sensitivity of mercury in glass thermometer can be defined as change in length per unit change of temperature. So centimeters per degree Celsius represents the sensitivity. If you have more centimeters per degree Celsius, then it's a sensitive thermometer. But if we define generally, this is only for mercury and glass thermometer. If you define generally, the sensitivity can be defined as generally sensitivity is the change of apparent generally sensitivity is the change of apparent quantity for a unit change of actual quantity. So generally sensitivity is the change of apparent quantity for a unit change of the actual quantity. So we can say that sensitivity is change of apparent quantity per unit change of actual quantity. So change of apparent quantity for a unit change of actual quantity is called the sensitivity. So this is the definition of sensitivity. That is the exam definition. Now sometimes the calibration curves will be, acha, in simple words, what is a calibration curve? If you plot a graph between apparent quantity, if you plot a graph between apparent quantity versus the actual quantity or vice versa, or it could be actual on the y-axis, both are acceptable. If you relate actual quantity with apparent on the x-axis, it doesn't matter. So these graphs are called calibration curves. One thing, what would be the gradient of this graph? Gradient of this graph will be equal to the change of apparent quantity over the change of actual quantity. And as you see, this gradient is actually the sensitivity, because sensitivity is defined as change of apparent quantity for a unit change of actual quantity. So this gradient here represents the sensitivity. On the other hand, if actual quantity is on y-axis, then you see the gradient would be change of actual over change of apparent. So change of actual over change of apparent. Here, instead of sensitivity, it becomes reciprocal of sensitivity. So gradient of this graph is 1 over sensitivity. So as you see, if you draw these graphs, then the curve or the shape of the curve will tell you about the sensitivity. If actual is on y, apparent is on x, then as you know, the slope or gradient is 1 over sensitivity. And if apparent is on y and actual is on x, then the gradient or slope is the sensitivity. Let's suppose you have this graph in both the cases. This graph shows it is becoming more sensitive. So if the graph is bending towards the apparent axis, then the divisions are getting bigger and the instrument is becoming more sensitive. And this instrument is, we can say that towards high values. As the values are increasing, the divisions are getting bigger. So basically it represents this thing. At low values, it is less sensitive. At high values, it is more sensitive. While on the other hand, in the second instrument, it is becoming, as the values are increasing, it is becoming less sensitive. So basically, initially the divisions are bigger and then they are getting smaller and smaller. So this is the second instrument. For this instrument, the slope of the graph here is 1 over sensitivity. Slope or gradient is 1 over sensitivity. An increase of slope or gradient tells the sensitivity is decreasing. Here the slope or gradient itself is the sensitivity. So this is the difference between the two graphs. This is the difference between the two graphs. Today we have to do up to this point. Then tomorrow we'll continue onwards. Take care, students.